The 787 came about because of customer demand, and the customer demand was we had a whole bunch of different types of planes we could have built. We could have built a plane that was the next generation of the Concorde. You know, the Concorde only carried 100 passengers. It was never an economical success. It didn't carry enough people, very expensive. We could have built a plane that went, you know, Mach 2.4, carried 300 passengers. That was called high-speed civil transport. We could have built a plane that was called the Sonic Cruiser, which flew close to the speed of sound. We could have built a plane that was super efficient. What we typically do is we have all these concept studies going on continuously, and then we take those and we discuss them with our customers, you know, in this case, the airlines, and we say, what do you need to make your business a success? Most of the airlines, when we came out with, you know, this range of planes, said they wanted something super efficient. So what was called the 7E7 was born, where the E was for efficient, the E was for, you know, E-enabled, you know, like the internet, and that's what the 787
And this is efficient became. In terms of?
The Phantom I is a hydrogen power airplane. It's got two Ford Fusion truck engines powering each propeller, but it's pure hydrogen, so zero emissions. And it flies for 4 days without landing. And so what we learned from that is, how do you handle hydrogen? Can we use hydrogen for an auxiliary power unit that you would use on the ground? Can we use hydrogen eventually as a fuel for a commercial airline? So it's all about combining technologies and learning. The other thing that plane does is it investigates the shape of blending the tube and the wing together into a single structure, because that can reduce the drag by another 30%. So again, more fuel efficient.
Given that it does have these sort of advantages, why aren't we seeing planes like that flying already? Why wasn't the new 787 some sort of blended wing?
Right now, I think we see it more as a tanker or a freighter. There are still, because it's so wide and there are people sitting so far away from the center line, there could be issues of, as the plane would, you know, roll a little bit, the motions of the people out at the edge would be uncomfortable. We're working on that. And the other is the airlines think that every passenger wants a window, and there'd be a lot of people far from windows. We're interested in being a catalyst for the industry, because we are convinced that sustainable biofuels can provide a way to reduce the amount of CO2 by between 60 and 80% on an airplane. And when I say sustainable, we're talking about biofuels that don't require land that you grow food on, that don't require water that you can drink, that use marginalized land, undrinkable water, where you can create an economy in a community that has nothing, and everybody can win. People that have poor economic circumstances can be brought up. You know, there's probably 80% of the fuel around the world goes through 75 airports, and so by having a variety of feedstocks, whether they're, you know, salt grasses or heteropha or algae, by having a variety of these sources around the world, we really do believe that by, say, 2030, 30% of all airplane fuel can be powered by sustainable biofuels.